Hi there and welcome. My name is Michael Kentenich and I'm a Microsoft Technical Trainer. In this video, we will unleash the power of seamless communication with Azure Message Queues services, Service Bus and Storage Queues. Message queues are crucial in the world of distributed applications. By decoupling sender and receiver, you enable your software solutions to communicate effectively, handle high volumes of messages, and ensure no message is ever lost in the process. Meet Max, a software engineer at a thriving e-commerce company. During the last Black Friday sale, the website crashed due to the overwhelming number of transactions. The inventory was a mess. Customers were billed incorrectly, and worst of all, many customers didn't receive their purchase confirmation emails. It was a nightmare. Fast forward to this year. Max implemented Azure Message Queues. Now, every transaction creates a message in the queue. The inventory, billing, and notification systems pull their respective messages independently at their own pace. The website handled the Black Friday traffic like a champ. The inventory was accurate, billing was spotless, and every customer received their email notifications on time. Max was the hero of the day. In this video, I will help you to choose the appropriate queue mechanisms for your solution and explain how the messaging entities that form the core capabilities of Service Bus operate. And we will identify the key components of Azure Queue Storage. Azure supports two types of queue services: Queue Storage and Service Bus Queues. Queue Storage belongs to the Azure Storage Platform. It lets you store many messages. A queue can hold millions of messages up to the total capacity limit of a storage account, which is a lot. Service Bus queues are part of a larger Azure messaging platform that supports queuing, publish, subscribe, and more complex integration patterns. They are designed to connect applications or components that might use different communication protocols, data contracts, trust domains, or network environments. Well, we have two services, so which one should we pick? Use Service Bus queues as a solution architect or developer if you want your solution to receive messages without polling the queue. With Service Bus, you can do this with a long polling receive operation using the TCP-based protocols that Service Bus supports. Or your solution needs to ensure that the queue delivers messages in a guaranteed first in, first out order. Or to enable automatic detection of duplicate messages. You want your solution to support transactions and atomicity when sending or receiving multiple messages from a queue. Or if the application handles messages that can be larger than 64 kilobyte, but will likely stay below the 256 kilobyte or 1 megabyte limit, depending on the chosen service tier. Although Service Bus actually can support and handle messages up to 100 megabyte. And lastly, if you plan to eventually switch from queue-based point-to-point communication to a publish-subscribe messaging pattern. This pattern allows integration of more receivers, subscribers. Each receiver gets independent copies of either some or all messages sent to the queue. Queue storage, on the other hand, is a good option for your solution if you need to store more than 80 gigabyte of messages in one queue. You need to monitor the status of processing a message in the queue. This can help if the worker that is processing a message fails. Another worker can then use that information to resume from where the previous worker stopped. Or you need server-side logs of all the operations performed on your queues. There are two stock keeping units for Service Bus that determine the pricing, the message size, and also the throughput, and some additional features that you can see listed on that slide. But I will use the whiteboard now, so we will first learn more about the differences between the queues and topics option that Service Bus offers, and then I will show you in a demo how to send and receive messages from a service bus queue. Service bus offers us queues and topics at the same time. The underlying mechanism is always queues, and I will explain what that means. But first, let's go over some characteristics of queues and how they're handled. So on a normal queue, we have a sender component that sends a message onto the queue. The messages are received in order that they are sent. So we have this concept of first in, first out. What that means here in this example is message 1 is the first one that was received, and it's also the first one that is going to be pulled from the queue. The receiver component or application is the subscriber, the component that gets those messages and processes them. But we can also, of course, give them the names publisher and subscriber, which is then referring to that pub-sub pattern that we have already a couple of times mentioned. Now, the receiver will, of course, at some point say, hey, let me have the first or the next message. And in Service Bus, we have two different receive modes available. The first one is called receive and delete. And it's the one that is used for most applications, and it's a very common mode. So what does that mean? The receiver will say, hey, give me that message. It will get that message. Service Bus will provide it. The message will be removed from the queue and the receiver can process it. On one hand, that is super fast because we don't have to wait for a response. But on the other hand, what happens if the receiver fails or is having a problem with processing the message? Potentially, that message can be lost. When the receiver has already started processing it, it is not stored anywhere, and there's no mechanism to put it back on the queue. That is not automatically happening on Service Bus side. So you can only use this if you can potentially tolerate messages being lost in this approach. That is the reason why this is called at most once are these messages delivered in receive and delete. Once it has been received by the receiver, it is not being made available on the queue. The second receive mode is called peak lock. This method makes sure that this message doesn't have to be lost. So we will make sure that there's a mechanism that we can react when the receiver is for some reason failing. So how does that work? When the receiver says, hey, I want to have that message, it will actually cordon that message, meaning it makes it invisible for other receivers on the queue. It will not remove it yet. It will just make it invisible. Now it will then try to process it, and if it has completely and successfully processed it, it will return back and say, hey, I did it. Now you can go ahead and remove this message from the queue. That way, we make sure that the normal case is all good. But what happens now if the receiver again fails while it's trying to process this and has already said, hey, I'm working on it. Now the message is not visible to others, but with this peak and lock receive mode, we can use and or configure either a timeout, meaning if the receiver is not coming back again or it's not going online, there is a certain time that where we release the message and put it back on the queue. And then the next time a receiver requests a message, it will get the same message. But of course, it could also be that this receiver is completely failing and will never come back. So the second criteria is to configure an abandoning method where we say, okay, we go and abandon this either on a call, or we say after a certain amount of time, we abandon this process. So we make this message available again and visible again on the queue, and we will just wait for the next receiver to pick that message up. So now you know about the two different receive modes that Service Bus queues offer. In this section, we learned that we have a one-to-one relationship between a sender and receiver component. In a queue, we're making this a bit more flexible in the sense that we have one sender, but we can have multiple receivers. So basically multiple components that can create a subscription if they're interested in receiving messages from a specific topic. A topic is basically a resource on its own and has multiple virtual queues configured. They all belong to the same topic, but you can have individual receivers, receiving apps, components that have subscribed these information or the messages for that individual topic. Each of those is an individual receiver subscribing to the same topic. All of these receivers have a subscription. They have subscribed to this topic, saying what this means, we have one topic here with 3 different subscriptions, and that allows us for that one-to-many relationship between sender and receiver component. And that is the difference between queues and topics in Service Bus. All the other things that we have talked about, so the first in, first out, and the different receive modes is exactly the same. Just the organization if you have either subscriptions for one topic and multiple receivers or a one-to-one relationship. In this video, I will show you how we can send and receive messages from an Azure Service Bus queue. We're looking at the Azure portal right now. I have a Service Bus namespace already deployed. If I open this up, you can see that it has a host name that we can read it by. In here, in a Service Bus namespace, I can create one or multiple queues or topics. In this demo, I will show you how you work with queues. I've created already one. If I scroll down here, you can see at the bottom, there's a message queue already. It doesn't have any messages yet. So if I open this up, we can see here, no active messages, nothing dead letters. So it's a fresh queue, was not used in anything before. Now, we need to have access from our application that is running elsewhere to this queue or the namespace. So we decide what we want to do. So we could create a shared access policy with a connection string that allows us access to the queue directly, or we could go one level up and then look at the shared access policy for the namespace itself. And that gets us access to all the different queues or topics. This is what I want to do right now. It gives you a little bit more flexibility, but of course you can be more specific. This has a root managed shared access key already created. You can create additional ones just for sending operation or listening. This is managing sending and listening capability that is created, and we have a primary, a secondary key, and the respective connection string for both. So I will just use and copy the primary connection string for now, because this is what I'm going to use in my code. And then I will go back to the overview and open up the queue already, because this is where I will show you the messages once they are sent. Now let's move over to Visual Studio Code. We have a message publisher application and a message reader application. So this is .NET, an example here. And what I need right now is the connection string. So to get that connection to that system in here, to the service bus, and you should not put this really in anything other than a demo file for this purpose. It's okay. In production, it's definitely not. So I have it in here. Then I provide the queue name. Message queue is the queue that I just showed you. We want to send 3 messages in total. And then here we create a service bus client that we then will use to send messages. So we instantiate this with the connection string. We create a sender that is bound to the queue name that we have provided. And then we have embedded this into a loop here where we send messages. So this message, and then the counter is too large to fit if that does not fit anywhere into that batch right now. That is just a catch mechanism, and then the actual sending takes place in here, where we have that send messages async, and when we will see a message saying a batch of number of messages has been published to the queue. So just a very simple example, also taken from the documentation, so nothing that you cannot just find on Microsoft Learn as an example as well. So let's save this first. And while I'm here, let's just do the same thing for the connection string in the receiving end. I will show you this later on. Basically, it's using also Service Bus Client. This time we have this processor mechanism where we receive the messages from the queue. So we will use this processing instance here to get access to the queue and then load those messages in here. And I have some error handling around it with this receiving component. So a very simple example on both sides. So let me save both of them and then open up the terminal. We start off with the publisher. So we'll run this, and then it should say that it has sent 3 messages to the service bus. So it says here, batch of 3 messages has been published. So let's check if that's actually true. So we go back to our service bus queue, refresh, and yes, indeed, we see now that there are 3 active messages in this queue. From this point on, all we know that works. Otherwise, the code will also have shown us an error message or anything. But there's also a nice feature in here that we can use the so-called Service Bus Explorer. With the Service Bus Explorer, we have a little tool built into the portal that lets us peek and also receive messages from the queue. So we have 2 different modes available, the peek mode, peek and log, and the receive and delete mode. With the peek mode here, we can actually just look into the queue without changing anything. So all the messages will remain on the queue. So I will peek from here, and you can tell, yeah, there are 3 messages in there. You can even select those and then have the message body sent in here. So you saw that we have message 1, message 2, and so on as the body. And you can even look at some of those properties here, the message ID, the sequence number, if it has been delivered already, maybe retried and all of these different things. But this is what we just, so you can look through this without dequeuing any of those messages. If you would change this now to receive mode, then you can get messages received. So if I say, yeah, let's receive them, then that lets you pick again, do you want to peek and log, or do you want to receive and delete? So let's say I want to do this time the receive and delete. Number of messages is 1. So I will receive. So it will dequeue one of the messages. That is message 1. Same thing as before. It's the same message. And you can tell that the queue number of messages have now is now decreased by 1. So we have only 2 messages left on the queue. Let's figure out if that's correct. So let's go to our Visual Studio instance. Now we start the message reader. And now the expectation would be to only be able to receive 2 messages. Yeah, actually now you see that we have only received 2 messages, message 2 and 3. They are received in the order they were sent. So the first one that was sent was obviously message 1, then 2 and 3. So we have that FIFO guarantee with Service Bus Queue. And yeah, that concludes this simple example, how you can send messages to a queue with Service Bus and also pull them down the queue. Azure Queue Storage is the second message-based service we cover in this video. It's the best fit when you have to store a really large number of messages and your queues grow larger than 80 GB. Azure Queue Storage is part of an Azure Storage account that will host this service. In the next demo, I'm showing you how to send and receive messages from an Azure Queue Storage. In this video, I will show you how to send and receive messages from an Azure Queue Storage. Azure Queue Storage is part of a storage account. I have already a storage account that I'm using for this. And as you know, a storage account has different storage services, one of them being queues. So if I look into this, I have 2 different queues, but I will only use one of them for this video. and this is the storage queue. If I look at this, it's currently empty. There are no messages onto it, and I'm going to send and also retrieve messages using code. Now, I will do this again with Visual Studio Code, and for this I have prepared already some C# code where I have loaded the library in here, the Azure storage queues, for all the methods that I'm going to use. Now, in terms of authentication, there are more and better ways of what I'm going to show you, because what I'm doing here is connecting to the connection string using the access keys for the storage account. And that means this application has access to the whole storage account. But there are better ways of doing this, using RBAC for this, using the Azure credentials, using user-assigned managed identities to specifically allow only an application to either send or pull messages from the queue. So this is really just a quick and dirty solution here, and you should really think about using that least privilege approach when you implement this in your solutions. And I copied this over obviously from the portal. So I will use a queue client using that connection string and the name storage queue. This is what I just showed you right now. And then the little program, the little console app here that's taken from a tutorial will do it like this. So if there is a command line option, now it's if I have arguments providing when I run that program, then it will insert a message into the queue. That insert message async is a method that I have created in here in this code. I will show this in a moment. But if there's after my .NET run a message parameter, then it will send it to the queue. If it's empty, if there's no parameter given, then we'll just retrieve the messages, right? So it will retrieve the next messages from that queue. So let's have a look how that is implemented. So first, the insert message async is connecting to the queue, and then we'll use this send message async method that is provided. And other than this, it will also at that point in time, I already have the queue created, but even if it would not be there, it will automatically do this. And it's a super easy to use method in here that says create if not exists, meaning it will check if it exists. If it's there, then it's good. If not, it will create it. So that leaves you also with some nice clean code and not try it before if it's existing or not. So then with the retrieve next message, then we use a delete message async operation, because what we're doing here is we're dequeuing the message from the queue. Keep in mind that in general, the mechanisms we're using the queue is similar to what we have with service bus queues, but there's a lot of these features like deduplication and other things that are important that the storage queues are not offering. So it's a more simple approach, but very useful if you have large queues. And then, it's basically also has this code in here where when the queue is empty, it actually deletes the queue. So that always clean up. So very nice and easy example. So let's run this. So as I said, if I'm going now to use .NET Run and I say, let's send the first message, then it will use that connection string, connect to the queue by the name, and then place that first message onto the queue. And yes, I did not fix all the warnings in the code here right now, so that's just me being lazy. So I will send a few messages just to have a little bit of a selection here. So we have two different messages. So first of all, let's check if that's actually true. When we refresh now, we can see that, there are two messages. There's no peeking or anything from in here, because I really can just, open this up. I can see the message body. In that sense, yes, there is peeking. So I can open this up. I can see what is the actual message, but not more that I could see anyway in here. So it's not dequeuing that message specifically, right? So, but it has been sent to the method, and that's all there is. There's not this nice and easy storage or queue explorer that we have with Service Bus. So now let's do the same thing. or not the same thing, but let's run it without any parameters, and that should get me the message that is the next message, meaning the first one. We have also, it will send, or it will pull the one that was first sent to the queue. And now if I check back, that has just pulled the first message, and now there's only one over. So you can tell that is a very simple example, very simple tutorial here. There are more available on Microsoft Learn if you want to look more into this and how to do this with Python and Java. We have these examples all there. So get an idea of what you want to do and then try it out. If you want to do this with queue storage, then this is the way to do it. In this video, I helped you choose the appropriate queue service for your solution. And we explained how the messaging entities that form the core capabilities of Server Bus operate. And then finally, we looked at the key components of Azure Queue Storage. Now, congratulations on grasping Azure Service Bus and Queue Storage integration. By utilizing .NET and other platforms, you are empowered to send and receive messages seamlessly, ensuring reliable communication between components of your solution. With Azure Service Bus and Queue Storage, enhance the reliability and scalability of your messaging infrastructure with ease. Thanks for watching. Keep on learning.